If you woke up today, December 8, 2025, and felt like AI suddenly grew a pair of hands and went to work, you wouldn't be wrong.
Not at all.
For the last couple of years, we've been really stuck in what you could call the chatbot era. AI that talks, that writes, generates images.
Right. It's been all about content.
But the stack of sources we've reviewed today, it confirms a definitive story. We have pivoted. We've moved hard into the agency era.
Yes. This is AI that acts. It executes, it codes, it manages logistics. It even influences real-world decision-making.
And that kind of shift from talking to doing, that requires immense structural support.
It does. And what our data shows is this massive coordinated global effort to build out the infrastructure. We're talking physical, digital, and policy infrastructure to sustain this new generation of, well, acting AI.
So our mission today is to cut through all that noise, the research papers, the high-stakes M&A, the government mandates,
Right.
and give you the critical updates, the things you absolutely need to know across technical, commercial, and policy fronts.
We have a really dense stack today. It spans research on model robustness, major product pivots into wearables, enterprise agents, and some really high-stakes government actions in the US, India, and Russia. So let's just dive right in, starting with the bleeding edge in research.
Okay, segment A. What I'm seeing in the research is a new maturity. We're moving past those simple, generalized scores we tracked last year.
We are. The new focus is hyper-specialized. It's about robustness, high-fidelity benchmarks.
Because if AI is going to act on its own in the real world, it has to be reliably accurate.
And reliably numeric, which is why our first major finding is the release of the chart anchor benchmark for chart comprehension.
Okay, so a benchmark just for reading charts.
Exactly. Researchers introduced this new multimodal benchmark. It's focused on tasks like generating Python code to recreate a chart, or, and this is key, extracting exact numeric data from a visual.
Why does that specific focus on charts matter so much right now?
Because the big general models we have now, they often hallucinate, or they approximate numbers when they read a graph. And if you can't trust an AI to read a simple bar graph accurately,
Then you definitely can't trust it with financial reports or clinical trial data.
Precisely. Chart Anchor gives us a test bed of over 8,000 real-world charts, and it just exposes these severe limitations in numerical accuracy for even the best models. It's all about pushing for verifiable precision.
Okay, staying on benchmarks, we also saw the release of the M4 ARAG multilingual multimodal RBAG benchmark.
Right, and ARAG, that's retrieval augmented generation, has been the go-to solution for grounding these models in real, up-to-date data.
So what's new here?
This is a massive benchmark. It covers ARAG performance across multiple languages, multiple modalities, using image question pairs across, get this, 42 languages and 56 regional dialects.
Oh.
But the key insight, and this is fascinating, it's really counterintuitive, it challenges ARAG's role as this universal fix for everything.
You mean the finding that RAG helps smaller models but can actually hurt the performance of the bigger ones?
Exactly. It flies right in the face of what most developers would expect.
So what's the theory? Why would it degrade performance?
Well, the hypothesis is that the really capable large models sometimes just get confused by the retrieved documents. They treat the RAG output as a retrieval noise, and it disrupts their already strong internal knowledge.
But smaller models need it.
Right. Smaller models use it as a crutch, and it helps them a lot. It reveals this really critical mismatch between model scale and how effective our retrieval systems are right now.
Okay, let's shift from general understanding to a really specific problem. Time series forecasting. It's notoriously tricky. We have a new model out of Russia, HNMVTS, for hyper-network-based time series forecasting. What problem is it solving?
Well, with time series, you're trying to predict many different variables that all influence each other. Think stock prices, temperature, electricity demand. You have models that look at all channels together, channel dependent, or CD, and those that look at each one separately, which is channel independent, CI.
And there's a trade-off there between robustness and precision.
Exactly. So this new architecture, HMVTS, it uses a hypernetwork to dynamically generate the parameters for that final prediction layer. It basically blends the robustness of the CI methods with the precision of the CD methods.
And the practical result?
It's a huge jump in real-world reliability. On the really tough weather dataset, it cut the delinear model's mean squared error from 0.1369 down to 0.1115 for a 48-hour prediction. That's a game that translates directly into better business decisions.
So if we're getting better at predicting the weather, I guess the next frontier is predicting human behavior. And this next one is surprising research on digital twins of future selves influencing decision-making.
This is AI intervention on a really personal level. Researchers used AI to generate avatars, digital twins of participants' future selves to simulate their life paths.
And interacting with these AI-generated futures actually changed what the participants did in the real world.
He did.
Wait, so AI is basically running a personalized version of Scared Straight on us, or maybe future inspiration.
In a way, yes. But here's the critical part. The intervention was most effective for people who already had high personal agency, the belief that they can influence outcomes.
So it's not changing the minds of people who feel helpless.
No, it seems to be empowering those who already feel capable. The avatar interactions explained about 25% of the variance in decision changes.
Okay, that shift from research to real-world action is probably most visible in our next segment on product launches.
Absolutely.
Let's start with Google. They're confirming a very aggressive re-entry into consumer hardware. Google announces AI glasses with Gemini for a 2026 launch.
This is their big push into what they call ambient computing. The idea is to move AI off your phone and into your immediate environment. They confirm two types, audio only and one with a display, and crucially, they're partnering with fashion brands.
Hold on. Google has tried this before. Google Glass was a notorious failure. Is partnering with a brand like Warby Parker and the $150 million they've committed, is that enough to overcome the graveyard of failed smart glasses?
Well, the big difference is the AI itself. Gemini makes this a fundamentally different product, and they've learned from the fatal flaw of the past. Smart glasses have to be desirable fashion accessories first, before their computing devices. This time, the AI is the feature and the fashion is the form factor.
So if AI is leaving the phone, it's also diving right into our work lives. Anthropic announced Claude Code integration in Slack.
This is a perfect example of agentic AI. It's seamless. Developers can now just tag at Claude in a Slack channel to assign coding tasks, generate fixes, answer technical questions.
And it uses the context from the conversation thread itself.
From the entire thread. It's not a separate window anymore. The Claude Code model is now effectively a functional junior engineer that sits right in your team chat.
That streamlines things.
It absolutely does. It goes right from discussion to automated code.
Meanwhile, Meta is trying to make sure its own AI has the freshest, most legally sound data. They've announced news partnerships to supply real-time content.
This is a smart dual strategy. One, they get access to essential real-time info. Two, they solidify their legal data sourcing. They announce deals with major news outlets CNN, Fox News, Le Monde Group, USA Today to integrate their content directly.
And this is to compete with rivals like X's Grok.
Exactly. It enhances Meta AI's factual accuracy, especially on time-sensitive queries, where Grok has faced some questions about its data sources.
Now, on the biggest possible scale, the U.S. Department of Defense is making AI an immediate operational necessity. Their plan is to deliver AI at scale to 3 million users.
3 million? That's a massive number. It makes this the administration's largest push for military AI adoption, and it's a real inflection point.
How so?
Because the DoD isn't trying to build everything in-house anymore. They're moving to leverage commercial partnerships with companies like Anthropic, xAI, OpenAI, and Google. They want to rapidly deploy AI for efficiency, intelligence analysis, and complex warfighting logistics.
They're buying the capability, not just building the tech.
Precisely. They're buying agent capability.
And finally, for a sense of where we are as consumers, Comscore just released its 2025 AI Intelligence Report. How deep is this in our daily lives now?
The report gives us new benchmarks, and they confirm this accelerated shift into mass market behavior. The key numbers show that AI assistants are now used by 36% of desktop users.
56%.
And 24% of mobile users. So this isn't just a niche product for early adopters. The jump in the last year confirms generative AI is now deeply integrated into daily workflows, both personal and professional.
So whether it's Claude as a junior engineer or Gemini on your face, the agency era is here. But none of this happens without massive infrastructure investment.
That's right. And that brings us to the physical foundation of this new era. The underlying story today is all about the infrastructure needed to power and manage agentic AI.
And the headline here is absolutely huge. IBM is acquiring Confluent for a staggering $11 billion to anchor agentic AI. That kind of price tag says real-time data flow is the new battleground.
It absolutely is. Confluent is built on Apache Kafka, which is a platform designed for high-volume, low-latency data streaming. If an AI agent is a self-driving car, then Kafka is the real-time radar and map feed that lets it navigate a complex city without crashing.
So IBM needs this for their smart data platform.
They need it. It's essential for any AI that requires constant situational awareness and real-time monitoring. The market certainly agreed. Confluent shares shot up nearly 30% on the news.
The need for speed continues on the cloud side, too. AWS just debuted GPU-accelerated vector indexing on OpenSearch service.
Yeah.
Okay, for those of us not building a RAG architecture, can you quickly explain vector indexing?
Sure. When a model retrieves information in a RAG system, it searches through huge databases of embeddings. These are just mathematical representations vectors of text or data.
So the index is like the library catalog for all that math.
That's a perfect analogy, and it has to be incredibly fast to avoid latency. So better indexing means faster and cheaper RAG applications. By launching this GPU-accelerated indexing, AWS is just dramatically lowering those latency and cost barriers. Customers can now build billion-scale vector databases in under an hour. That's up to 10 times faster than before. It makes large-scale RAG practical.
Now for the geopolitics of silicon. We saw two major and seemingly contradictory stories about NVIDIA chips in China. First, President Trump announced an NVIDIA H200 AI chips export approval with a fee.
Right. This is a really nuanced policy. It's designed to ease some of the prior restrictions to maintain market access for U.S. companies like NVIDIA. The government wants to stay competitive globally.
But there's a catch.
A big one. To exert control and, frankly, extract revenue, each chip exported will have a stiff 25% fee tacked on that goes to the U.S. government.
And yet, at the same time, the DOJ announced they shut down a $160 GPU smuggling network. So enforcement is getting tougher.
It is. This really highlights the intensity of the demand and the high-stakes game being played. The DOJ disrupted a network that smuggled at least $160 million worth of these export-controlled H100 and H200 chips to China. So even with the new fee structure, the U.S. is still going to be very aggressive against any unauthorized channels.
Okay, finally, let's talk about the massive power challenge.
Yeah.
These AI clusters run incredibly hot. They use so much energy. India seems to be addressing this with the NVIDIA GaN chip partnership. What is GaN?
GaN stands for gallium nitride. It's a high-efficiency semiconductor material, and it's far superior to traditional silicon for managing electrical power.
And you need that because when you're running thousands of GPUs in a data center, power and heat become your biggest problems.
They become the limiting factors, exactly. GaN is critical for managing that energy demand. So this isn't about computational power, it's about power efficiency. So this partnership between US-based Navitas and India Scient does two things. It addresses the need for energy efficiency globally, and it diversifies the supply chain away from traditional hubs, which really helps India's own domestic tech ecosystem.
And as AI moves into these high-stakes roles defense clinical systems, the policy is moving from abstract principles to really specific mandates.
And fast.
In the U.S., the news was explosive. A proposed U.S. executive order for a single national AI rule.
President Trump announced his intention to sign an executive order that would create a unified federal AI regulation. The idea is to preempt and supersede all the individual state laws.
Which the big tech firms have been lobbying for.
Heavily. They want to simplify compliance.
I can see why. Replacing the potential compliance nightmare of 50 different state approvals with one rule would accelerate everything. But that sounds like a major federalism clash waiting to happen.
It is. State leaders have already voiced opposition to having their regulatory autonomy stripped away. The tension is between streamlined commercial innovation on one side and the state's power to regulate things like employment and local services on the other. This battle is really just beginning.
Meanwhile, India is taking a strong lead on the ethical front. They've mandated bias mitigation in AI governance guidelines.
Yes, India's Ministry of Electronics and Information Technology, or MeitY, has directed all developers under the India AI mission to prioritize very stringent bias mitigation and stress testing.
Which is especially important given the diversity in India.
Extremely. With the regional, caste, and gender diversity there, this move positions the country as a global leader in ethical governance. It mandates that their sovereign LLMs have to be inclusive and non-discriminatory.
And in the clinical vertical, governance has also matured very quickly. A review identified critical appraisal tools for AI in clinical studies.
This is a signal of rapid and necessary maturation of standards in healthcare. The review found 46 tools for appraisal and reporting. It highlights the mismatch between these new types of AI bias and traditional epidemiological bias.
So tools like Quadus AI and Probast AI are becoming requirements.
They are. And that raises compliance costs and creates new regulatory barriers for any developers targeting the clinical sector.
And finally, a quick look at Russia, where policy is also being engaged at the highest level.
That's right. The Russian Duma chairman, Vyacheslav Volodin, met with President Vladimir Putin to discuss the need for more oversight and legal frameworks for AI governance.
Which signals what?
It shows active engagement from Russia's top leadership. It suggests potential regulatory developments are coming, driven by concerns over the risks of deploying high-autonomy AI in critical government applications.
Okay, that was a dense dive into the material for December 8, 2025. If we zoom out, what really stands out to you about this big shift from AI that talks to AI that acts?
It's the synchronization. The pivot to agency in the software, Claude fixing code in Slack or the DoD using commercial models for logistics, it is entirely dependent on the huge investments in physical infrastructure we saw today.
The software and hardware have to move together.
They have to.
Yeah.
That $11 billion IBM deal, the specialized GAN chips in India, it all shows that the future of AI is now less about chat quality and more about data flow, power efficiency, and verifiable action in the real world.
For those of you looking to dive a bit deeper, let's leave you with a couple of tools you can use today.
For developers or researchers focused on performance, definitely check out the Shard Anchor benchmark released on ArcC. It includes the dataset and the code for rigorously testing how well your models actually understand charts.
And for engineers.
For engineers dealing with complex time series data, the code for HNMVTS, that's the hypernetwork-based multivariate time series forecasting model, is available on GitHub. You can use it to immediately boost the robustness of your forecasting models.
All right, and now our numbers of the day.
Number 1, $11 billion. That's the price IBM paid for Confluent. This just screams that real-time data streaming infrastructure is now the essential, non-negotiable ticket to the game for enterprise AI.
Number 2, 36%. That's the percentage of desktop users now relying on AI assistants for daily tasks, according to ComScore. It confirms AI has shifted from a novelty into just mass-market routine behavior.
Today's headlines confirm that AI is moving into these very high-stakes operational roles defense, clinical systems, core IT, and it requires staggering multi-billion-dollar outlays for specialized hardware.
So there's a problem.
There is. We know that while hardware vendors like NVIDIA are making massive revenues, many of the industry heavyweights, including some of the largest model providers, are still struggling to find a consistent profit model to fund these hyper-expensive systems. So the question for you to think about is this. Can the massive and increasing costs required to buy the latest generations of hardware sustain this industry's exponential growth before the operational profitability of these AI agents is finally proven? Something to mull over until our next deep dive.